Welcome to the Tech Mechanic. Today's breakdown is part of our AI Architecture Master Series. If you want the full roadmap, then hit the playlist from the start. With that said, let's dive into today's topic. Imagine you tell an AI, check today's sales, find the failed payments, create a report, and send it to my manager. A normal chatbot might tell you how to do it. But what if the AI could actually perform those actions? What if it could access a database, call an API, create a report, and send an email? Now we are moving beyond chatbots. We are entering the world of AI agents. The easiest way to understand an AI agent is to compare it with a traditional chatbot. A chatbot primarily responds to a conversation. An agent is designed around achieving a goal. It can determine what action is needed, select an appropriate tool, execute that tool, inspect the result, and decide what to do next. So the big shift is from answering questions to accomplishing tasks. So where does the intelligence come from? In many modern agent architectures, the LLM acts as the reasoning engine. It interprets the user's goal. It determines what information or actions may be needed. And based on the available tools and instructions, it can decide what to do next. But an LLM alone can't magically access every system in your company. That's where tools come in. Think of the LLM as the brain. Tools are the hands. Like a tool could be a database query, an API call, a web search, an email service, a calendar, a CRM system, or even a payment system. The agent decides when a tool is useful and passes the appropriate information to it. This is what allows AI systems to interact with the real world. One of the key technologies behind tool using AI is function calling, also known as tool calling in many modern AI platforms. The model doesn't directly execute the function. Instead, it can produce a structured request describing which tool should be called and with what arguments. The application executes that tool. The result is then returned to the model. The model can use that result to continue the conversation or workflow. Now we have the basic agent loop. The user provides a goal. The agent reasons about what needs to happen. It selects a tool. The application executes the tool. The agent receives the result. It evaluates whether the goal is complete. If it isn't, it may perform another action. And eventually, it returns the result. This loop is one of the fundamental patterns behind agentic AI. Let's make this real. Imagine our shopping application. A customer asks, "Where is my order?" The agent doesn't need to guess. It can identify the customer, call the order service, retrieve the order information, and potentially call the shipping service. Then it can combine those results into a simple answer. Your order is out for delivery and should arrive today. That's an AI system interacting with enterprise systems. Now let's connect this with our RAG journey. Agents and RAG can work together. RAG can provide knowledge from company documents. Tools can provide live information from enterprise systems. APIs can allow the agent to perform actions. The LLM coordinates these capabilities. So our architecture is becoming much more powerful. Knowledge plus tools plus reasoning plus actions. Here's an enterprise example. An employee asks, "Check my remaining leave and submit a vacation request for next Friday." The agent may retrieve company policy through RAG. Query the employee system for leave balance. Call the HR API to submit the request. And finally send a confirmation. Notice what happened. This isn't just question answering anymore. The AI is coordinating multiple enterprise capabilities to complete a business task. Let's look behind the scenes. The user sends a request. The agent sends the relevant information to the LLM. The model determines whether a tool is needed. The application then executes the selected tool. The tool returns its result. That result goes back into the agent workflow. The model can then generate the final response or decide that another action is necessary. This separation between reasoning and execution is extremely important when designing enterprise agents. Let's take a look at how an AI agent uses workflow tools to complete tasks, proving it is much more than just a chatbot. Imagine you are a marketing manager. Every day, your team pitches new campaign ideas. Sometimes they send a long email, sometimes a quick chat message. The information is often messy, unstructured, and missing key details like the budget or target audience. Normally, you would spend hours manually reading these messages. You would have to copy the data into a tracking spreadsheet, check if the campaign already exists, and finally sit down to write a formal campaign brief for your creative team. It's a massive time sink. That is the exact problem this workflow solves. We needed a fully automated assistant. The requirement is simple. Catch these messy, incoming requests the moment they arrive. Have AI instantly read them, organize the data, and flag if anything is missing. Then, log it neatly into Google Sheets and automatically write a polished, professional campaign brief. What used to take hours of manual copy-pasting now happens in seconds. Now, it all starts with a webhook trigger that receives an incoming campaign request. The raw data is instantly sent to an OpenAI node called Extract Campaign Information. Here, GPT-4 processes the messy input and structures it into a clean Gesso format, isolating key details like brand name, budget, audience, and timeline. Next, we have a quality check. The Validate Campaign Fields node ensures that essential information like brand name, campaign type, and objective are present. If data is missing, the workflow routes to the Mark Incomplete node, stopping further action. If the data is valid, it proceeds to Google Sheets to search for existing records. Based on whether the campaign already exists, the flow branches out to either update campaign information for existing entries or create campaign for new ones. Once the record is logged, both branches merge back into the Generate Campaign Brief node. OpenAI steps in again, using the structured data to draft a comprehensive, professional campaign brief. Finally, the Update Status Approved node pushes this finalized brief back into our Google Sheet. We can test using Postman from Execute the webhook and will update in Google Sheet. We can check now all the data is created or updated. And just like that, we've turned a raw webhook payload into a fully logged and drafted campaign brief, completely hands-free. Now here's the part architects cannot ignore. Giving an AI access to tools also gives it the ability to cause real-world consequences. Imagine an agent accidentally calling a destructive API. That's why enterprise agents need guardrails. Authorization, least privilege, input validation, tool restrictions, monitoring, and for high-impact operations, human approval. An intelligent agent without proper controls can become an intelligent way to make mistakes faster. Not every action should be fully autonomous. For low-risk actions, automation may be appropriate. But for high-impact actions such as financial transactions, deleting data or changing production infrastructure, we may require human approval. This creates a human-in-the-loop architecture. The AI prepares the action. A human approves it. The system executes it. That's often a much safer enterprise design. Now let's put everything together. The user interacts with the AI application. The agent coordinates the workflow. The LLM provides reasoning. RAG provides enterprise knowledge. Tools provide access to APIs, databases, and business systems. Memory can maintain relevant information across interactions. And guardrails control what the agent is allowed to do. This is starting to look like a real enterprise AI architecture. Let's see how far we've come in this masterclass. Level 1. Chatbot, answer my question. Level 2. RAG, find relevant information and answer using it. Level 3. AI agent, understand my goal, retrieve information, use tools and take action. This progression is extremely important. We are moving from AI that talks, AI that knows, AI that acts. Here's your architect challenge. Your company asks you to build an AI customer support agent. The agent should answer questions using company knowledge. Check order status, create support tickets, and potentially process refunds. Would you simply connect an LLM? No. You need an agent layer. RAG for company knowledge, tools for enterprise systems, security and authorization, guardrails, monitoring, and human approval for sensitive actions. That's the difference between a chatbot demo and an enterprise AI architecture. And remember, an LLM generates, an agent coordinates, tools execute. Whether your goal is to become a solution architect, cloud architect, AI architect, or simply a better software engineer, the Tech Mechanic is your learning destination. Like this video, subscribe, and hit the bell icon to stay ahead in your tech journey.